Right. So all of these videos will be recorded and uh, stored on the learning management system. But I have just switched on the recorder right now, because I forgot to do that. So we missed the last 10-15 minutes. And thanks to Sarfraz for reminding me of doing that. In addition, you will have access to all the slides. You will have, or you will also, I'll also be uploading a bunch of reading material, articles related to cloud and AWS and the technologies we will be talking about on the learning management system. So if you miss a class, you can basically go to the LMS and view the recorded version of the class, and you can, or you can just replay the class if you want to revise some topic, and this will be accessible to you, forever essentially. Does Rackspace use AWS? So the answer to that is no. Rackspace is actually a competitor of AWS, and earlier on they had their own software, essentially to manage to build their cloud system. But lately, I think they have been using a combination of OpenStack and probably also CloudStack. And we'll talk more about these. Basically, OpenStack, CloudStack, these are software frameworks that help that enable someone to build a cloud of their own using commodity hardware. So commodity servers, storage, networking, things like that. So Rackspace is heavily moving towards using those, and these are open source. So OpenStack and CloudStack are open source software that are driven by the open source community, as well as a lot of support by companies such as Citrix, NetApp, and so on. Okay, so there's a question on, is Quanta selling open computing hardware in India? So I am not familiar with Quanta, and I'm also not familiar with open compute hardware. So I don't know. Maybe if you want, I can if you send me a mail or ask this question on the forum, I can research on it and get back to you. Okay, so we'll get started with the next module of this course, which is essentially, I'm going to talk about what is cloud computing and what are the different aspects of cloud computing and things like that. So first there's a question for all of you. So if you were going to develop a new application, what kind of application would you develop? So think of, put yourselves in the shoes of an application developer. So let's say you're developing maybe some accounting application or a human resource management application, or a project management application, and anything, any kind of application that you've been using on the in your life so far, or could be an email application or a social network application like Facebook or Twitter. So what kind of application will you develop? Any thoughts? So will you develop, let's say, a yeah, I'm not talking about the domain of the application. I'm talking at a more technical level. So will you develop the application should be like, for example, will you develop a Windows GUI application, or will you develop a client server web application, So Aditya says client server web app. Okay, but Aditya, what about mobile app? Right now, the hottest thing is mobile and tablet cross platform. Okay, so Aditya is saying that a web application can essentially be used by any computing device that has a browser. But I mean, if that was the case, why are there like all there are so many app stores, iOS App Store, Android, the Google Play Store, and these have hundreds of thousands of applications. The new applications getting created every day. So at least there are people out there who are saying that uh, there are people out there who are thinking that they want to develop not just web applications but mobile applications as well. But essentially, I think the trend is towards either web applications or what's called hybrid mobile application. So web application is essentially something that runs in your browser. So very great examples are Facebook, Twitter, Gmail, uh, Google Docs. So Google Docs runs a essentially word processor, spreadsheet processor in your browser. So these are all web applications. So a bunch of the stuff runs in the browser, and then a bunch of the a lot of the processing is done on Google or the vendors servers. Then there's another thing called hybrid mobile application. So these are so what people have found out is that web applications don't really work well for mobile uh, because they just don't have that great experience as a native mobile application. Plus, they let's say if one of the advantages of these uh, app stores, mobile app stores, is that they help you discover a new application and discover, download, share, review, talk about these mobile applications. So because of this, there is a lot of benefit in building a mobile application versus a web application because because of the experience and the ability to distribute via these app stores. However, when you build a mobile application, a native mobile application, it has the same challenges as a desktop application. Like it's hard to upgrade and things like that. So there's a thing called hybrid mobile application, which is essentially you can download the application via uh, the app store, but the mobile application, a lot of the functionality of the mobile application is conducted. It's essentially a web application embedded in a browser, and the browser is itself embedded in a in the mobile application that you download. So these are both of these are examples of what's called SaaS or software as a service, and because and we'll look at some of the advantages and properties of SaaS in the next slide. So what are the benefits of SaaS for customers? So firstly, you can access the application from anywhere and any device, right? So for example, Facebook, we can access it from any computer, and then if you want, we can just go to a friend's computer or a shared computer in our lab and access Facebook from there as well. Then there is easy distribution because if I have to use Facebook, I don't have to install something on my PC. I just go to facebook.com and start using the application. So this makes it much easier to get started with. There's no installation, there's no setup that I need to do before using the application. There's absolutely zero infrastructure on the at least for the customer. So let's say I'm a user of Gmail or Google Docs. What is the infrastructure I need? I just need a PC or a tablet. I don't need to have servers. Um, I don't need to have any. Okay, another benefit is low initial cost because these applications tends to have a subscription model, which is like you pay a fee every month for using it, or they could just be free as well, like Facebook and Gmail. But even if it's paid, it tends to have a subscription model on a monthly basis or yearly basis, which means that there is no upfront cost. And compare that to, for example, applications from if you know applications from more traditional software vendor like Adobe. Adobe applications can cost several tens of thousands of dollars upfront, plus renewal fees every year for maintaining the license. Then another great benefit is a seamless upgrade, because with software needs to be upgraded um, periodically because of new enhancements, bug fixes, things like that. With SaaS or software as a service, uh, the benefit is that we can just upgrade the software uh, on the vendor side, and we don't have the burden of updating the software on every customer. So, for example, uh, there are sites like Quora.com which are known to upgrade or change their software almost on a daily basis, even multiple times a day. Now, if there was some kind of if the software had some components installed on the customer's device, this would obviously not be possible, because as a customer, think about it. You don't want we hate upgrading. Even uh, uh, for example, even with mobile apps, it's not very easy to it's not very difficult to upgrade mobile apps, but still we have to uh, every time I go to the Play Store, there are like 20-30 updates for me, and I hate it because it takes a long time to download those updates, apply those updates, and while it's doing that, my phone becomes very slow. And for example, Facebook, Quora, Gmail, these guys can just update it on the servers themselves without any burden on the customers. Then another great advantage is data backups and recovery are taken care of. So think about your email. So your email is sitting in maybe a Gmail, and you absolutely don't have to worry about backing it up or recovering. If something went wrong, you don't have to recover it. Google will do all of that for you. Google takes responsibility of doing that for you. And as a customer, that's really great for me, right? So any other advantages, benefits, or even disadvantages of SaaS that you want to add? Any thoughts on so we are talking about benefits. Do you see any disadvantages of SaaS? Okay, so Sarfraz is saying everybody seems to be concerned about security, and why is that? What are the problems with security? There's no control on what? The security? Okay, good point from Ganesh as well. What if the provider shuts down their business? So uh, yeah, that happens. But typically, what the provider will do in that case is that they'll at least give some way for the customer to download their data. So I remember a couple of Google services getting shut down. So I think Google is in the habit of shutting down some product, couple of products every year, and they do give the option to their users to download their data. Yeah, Google Reader, you know, uh, Google Reader as well as Google Wave. Um, but yeah, that is null. Okay. Okay, but there are so security is a is a concern, and as so we'll see a little later is that security and privacy are the biggest concern for adoption of cloud computing, and a lot of that is to do with the um, with this there's this fear that uh, something would go wrong. You're not in control. Somebody else has access to your data. There could be software bugs that because there are always bugs in software. So there could be bugs that people can exploit to access your critical data, things like that. Even though even though the data centers in which these typically these SaaS services run are much better than any small company can even ever think to create, or even a large company can think to create. But security and privacy are definitely issues, and we'll talk about another reason, like a more technical reason why they are an issue. Okay, but now let's talk about another topic. So we've looked at the benefits of SaaS for customers. What is the effect of software as a service on the vendor? So think about an application that you use in the browser, okay? Facebook, Gmail, Quora, LinkedIn, or maybe some of the other smaller applications. But think about one of those applications and think what is the impact of SaaS on a vendor. So let's say uh, if you are going to create a SaaS or a web application, so it reduces sales. Uh, so the I'm not sure if it reduces sales, but basically with SaaS there's a different revenue model. With SaaS, typically the revenue model is based on monthly or yearly subscriptions, versus traditional software was based on a revenue model of very high upfront fees and about 10 to 20% renewal fees every year, as well as maintenance fees. So the maintenance fees is basically to make sure that you get software upgrades every year. Okay, Sarfraz, huge data centers and resources to manage. What do you mean by that? Abhi, patches, what do you mean by that? Skilled resources. So what does it mean? I mean, does the vendor need more skilled resources if they are going with SaaS, and if so, why? Skill set is changing. Okay. Windows OS versus upcoming Chrome OS. Yeah. So Abhi, these are all benefits for the customer. But what is the effect of SaaS on vendor? So let's take an example. Let's talk about Microsoft Word versus Google Docs. Okay, I hope that everyone of you have used Google Docs, or at least understand the concept of Google Docs. And it basically, these are the both of these are word processor applications, but they are very different. So Microsoft Word runs on my laptop. I can edit it, things like that. I edit it and save it on my local hard drive. Versus Google Docs, uh, it runs in my browser and Google servers, and I can edit the document there, and which is stored on Google. So now the document is stored on Google server. So Microsoft, the document with Microsoft Word, the document is stored on my laptop, but with Google Docs, it's stored on Google servers. And of course, there are the benefits of being able to collaboratively edit documents, able to share documents easily, and so on. But what I want to get to is, what is the impact on infrastructure or computing resources? What is the impact on computing resources for Microsoft Word versus Google Docs on the vendor? So what is the computing resources required for Microsoft, to be able to deliver the Microsoft Word functionality to its customers, versus what is the infrastructure required for Google to deliver Google Docs to its customers? Okay, Google requires huge investment on the server. Why? So are you saying that Microsoft doesn't require huge investment because of Microsoft Word? Right. So I think what Sarfraz is trying to say is that Microsoft Word essentially runs on the customers or the users infrastructure. It's running on my PC, which is owned by me, and I have to, it's basically my responsibility to manage that PC. It's my responsibility to take care of the performance, the backup, things like that. But for Google Docs, all these become the responsibility of Google, right? So plus, okay, note down, think about another point. So let's say both of these applications have 1 million users. Okay, Microsoft Word has 1 million users, and Google Docs also has 1 million users, as example. And let's say that uh, there is some amount of computing resources required to run the software. So we'll say this, for assumption, we'll say that 1 unit of computing resource is required for running Microsoft, and 1 unit of computing resource required for Google Docs also. So the thing is that with Microsoft Word, those 1 million computing resources are spread over 1 million users. But with Google Docs, all those 1 million computing resources are uh, are served by, or are the responsibility of Google itself. So does that make sense? Because now Google is responsible for serving the. So Google is responsible for. Yeah, I muted the newcomer. So Google is responsible for serving Google Docs completely, whereas for Microsoft Word, the resources are the responsibility of the user itself. So what happens is, with SaaS, the computing resources get consolidated at the vendor, which means that the vendor now has the burden, has to bear the burden of all the computing resources. And what does that mean? That means that you end up with you need more computing resources, so which means bigger data centers, more investment, in the data centers and things like that. Now Google is able to invest in that much because of the scale that they operate at. The scale and the uh, the amount of money they have. But think of what about a small application provider. So let's say a startup like us, or maybe a small company, 50, 100 people company that has a few customers. The thing is, what happens that all the burden of managing the infrastructure for that application is now upon them, upon the vendor, and this is a big burden. And because of this, uh, what the vendor this is driving the adoption towards cloud computing. So what happens is that, let's say I'm a small application vendor, and as an application vendor I want to focus on adding value to my application. I don't want to I don't really want to focus on actually running the application, because what has happened over time is that uh, running the application is more of a operational thing. There's not much innovation we can add in that. So as an application developer, what I want to do is kind of outsource the infrastructure management to an expert like Amazon Web Services, or okay, maybe not an expert, but at least somebody like Amazon Web Services that has that scale. I can go to Amazon Web Services and tell them that I want 2 more servers, and I can create them in a matter of seconds. Whereas for me, if I had to create 2 more servers, uh, it would be a much bigger process. Maybe getting the physical equipment, having the people to install and manage those servers and things like that. Okay, so what we've seen is that with software as a service, which is essentially a web application, the infrastructure burden shifts from the user or the customer to the vendor, and there's also this consolidation of computing resources on the vendor, because instead of having a small amount of resources used at every customer, now all of that is has to be consolidated at the vendor service server. So which means that we are replacing 100, let's say 1 million laptops by maybe 100 very powerful servers. Okay, now think about, so I think we've already talked about some of these. So if I'm a small application developer, these are the problems for me. Do I have the money for doing spending capital expenditure on buying servers or setting up my own data center? I do not. Then the amount of resources required. What happens is that initially when your application is small, you have few resources required, and the amount of we don't really have. It's not really clear as to what your resources requirement will be. Like if your application is popular, you may require double the resources in the next 1 week. Or there used to be something called the slash dot effect, which is that so slash dot was is I think still a very popular news site for computer professionals. And if an article got if a company, if an article about your company got published in Slashdot, you will suddenly get thousands and millions of people coming to your website, and that certainly increases the load on your website. And in a traditional kind of setup, how do you handle that? And then you need the flexibility to scale. I have 10 customers today, 20 tomorrow, 100 after a month. Now how do I quickly scale to handle those customers? As well as I can't really predict that. I can't really predict how many customers I'll have after 1 month. I could go from 20 to 100, or I could go from 20 to 25. It's very difficult to predict. So these are some of the benefits that cloud computing brings for a application developer. Okay, so we'll talk about computing as a service next. But any questions or anything that you want to discuss till now? Any comments? Any feedback? Okay, so let's talk about computing as a service. What does computing as a service mean? So a little bit of a historical context. So computing started out with mainframes, in the 60s, 70s, and these mainframes were huge computers, the size of one room, and they were owned by very few companies could actually afford them, and they were so expensive that there was no concept of a dedicated computer for every person. Instead, yeah, it could be many rooms. So there was no concept of a dedicated computer for any person. There was something called time sharing. So essentially, you had some work to do on a computer. Let's say you want to run some computational processing. So you'll create a program for it on something called a punch card, and give it to the operator. The operator will execute that program on at a certain time and give you the result. Then this was replaced by when mini computers and servers started coming in, especially with the Intel processors. It was replaced by big data centers, especially by companies, um, that could the big companies. They used to have their own data centers, or there were companies that outsource part of like, let's say one room, one rack in a data center to a particular company. And all this mostly what happened was that everyone owned their computing resources, and this led to a very high capital expenditure. In fact, there was even a time where the computing infrastructure could be a competitive advantage for a company. So if company one had had more powerful servers, they would somehow have more competitive advantage versus a competitor. But to do all this, they required a very high capital expense. So essentially, capital expense means upfront payment, versus the opposite of capital expenditure is something called operational expense, which means that payment as at a regular interval, let's say every month or every quarter. And along that time, people started thinking about why can't computing be like electricity, so or like water. So these are if I need electricity to power a light bulb at my office, I don't run an electricity generator, or I don't own an electricity generator. In fact, I just use electricity from a utility provider, and I pay them a pay as you go or a subscription fee for the amount of electricity that I use. And same for water. So I don't build a tank or to store a lot of harvest water, store it, clean it, things like that. I just use it as a service from my water provider. So there was this thought that people had, that why can't computing also be an utility? So there was this concept of utility computing. It was not really implemented as such before cloud computing, but it was a business model where computing could be delivered on demand. So on demand means like I have with my electricity. When I switch on the switch for the light bulb, I'm consuming electricity, and I can just switch it off, and I don't have to pay anything. So same with computing. So when I need a server, I'll use it. When I don't need a server, I'll just I should be able to just shut it off so that I don't get charged for it. Then pay as you go. So only pay for what you're going to use. So if somebody is going to somebody has 10 units of computing requirement, they should only need to pay for 10. So essentially, it was this idea of can we make computing also an utility, and cloud computing has essentially achieved this. So this slide has the technical definition of cloud computing, which is, and you can read through this, but it's essentially in the form of utility computing. It means using computing resources, which is both hardware and software, and delivering these as a service over a network as a utility. And we've talked about few properties of utility, that I can switch on and switch off the utility. I only have a pay as you go. I don't have any or I don't have a significant capital expenditure. Mostly it's operational expenditure and things like that. And then there's another definition. I think the second definition is from NIST, which is a body of the US government. So cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool. So the computing resources are shared rather than dedicated, and we'll talk about more what this means in terms of the technical technology. That can be rapidly provisioned and released within minimal management effort. So rapidly provisioned is another great attribute or property of cloud computing. Okay, and the next couple of slides just list down some of the hundreds and thousands of companies that are operating in the cloud computing domain now. So there are many companies on this slide, and these are software companies, infrastructure companies, application companies, all a large variety of companies, database companies, networking companies, hardware companies, all of different great variety of companies that are operating in the cloud domain. And same here, a lot of the well-known cloud companies on this slide, and then this slide as well. Okay, so talking about the economics of cloud computing, so it's like a utility. So you pay a standard fee for the computing resource, and you pay for only how much that you'll use. Okay, now one more thing. So here's, okay, let me go back. So think about this question. So let's say, and this is actually one of the assignments. So let's say you're going to set up your own data center. So maybe you're a company, and you need to want to set up your own infrastructure for whatever reason. Just tell me the heads or the items where you will incur cost for building your own small data center. And let's say this data center, you can think that it's a small data center, maybe 100 servers and 100 physical servers. So you need a room, real estate, right? Hardware resources. So hardware resources for the for building the servers, which include CPU, memory, motherboards, networking, right? So a variety of hardware resources you need, the cabling, things like that. Okay, air conditioning, very good. So we need air conditioning is very closely tied to data centers and servers, because the servers generate so much heat that you must have an air conditioner uh, in a data center to keep it cool. Power generators, yeah, especially for backup. So you need power generators or backup generators. Uh, Skilled personnel. Why, Aditya? Why do we need skilled personnel? What will they do? People, BMS. What is a BMS? Power supply. Yes. Yeah. What kind of skilled personnel do you need? So you need, you know, let's say you need a database administrator, because you'll have some databases. IT administrator. You'll need network administrators, right? You'll need people to who actually go and manage the data center in terms of the physical cabling, things like that, right? What else? Yeah, time, installing, upgrading. Uh, yeah, so upgrading, you need people who make sure that the software, the latest version of the software is running. So let's say if the database, let's say I'm using MySQL database. So if MySQL comes up with an upgrade, we need to make sure that it is passed on to all our servers. Electricians, maintenance, software. Yeah, so I think Ganesh is the first person to talk about software licenses. We need, if you're running a Windows or Oracle database, we need to pay a lot for the software licenses. So I think there were at least 10 to 15 heads, I think, that we covered. Now with cloud computing, what happens is that all of these are absorbed into a single fee. So a cloud computing provider can, and by the way, nobody talked about storage. I mean, I am from NetApp, right? So uh, there's a storage is very expensive as well. So we need to pay for the uh, disks and the storage software and things like that. Okay, so a cloud computing provider typically will absorb all these fees into a single fee or single cost for the computing resource, and we'll see that in the context of AWS, SAN, yeah, SAN, NAS, all those things, as well as backup software, disaster recovery software, uh, a lot of the storage management software and things like that. And I think what I want to highlight is that uh, which you probably already know is the hardware is one thing, but the a lot of the fees nowadays is the skilled manpower. Especially the administrators. Systems administrators are one of the most highly paid people in the IT industry. And different kind of systems administrators. You need, let's say, a Linux and Windows system administrator, or versus a DB administrator, a storage administrator, a network administrator, and because these are very specialized skills, and more than that, these are the whole running of the whole company. So let's say if I'm going to put my mission critical application on this data center, I bloody well make sure that this will not fail, because any failure of the data center means downtime for me, and which means downtime for my customers, which could have a great impact because of service level agreements, and there could be penalties and things like that. So no downtime can be afforded. So these and that's why IT administrators, uh, they are responsible for running these data centers, and that's why that it's such a high responsibility job, and because of that they are so expensive. Okay, so Pim is he's a systems administrator, I think, and I think he's asking a question which I think friends, let's help him get a job at the end of this course. Yeah, I think Ankit, it's probably the other way around. I think the great because of the responsibilities that the IT administrators bear, that's why they get such big salaries and money. I think it's the other way around. Responsibility, great responsibility brings great money. Okay, so the economics of cloud computing are typically it's pay for what you use, exactly like a utility. There are very low or zero upfront fees. Although this is, we'll talk about this upfront fees. It's it's a mixed bag. We'll talk about that. There is zero minimum usage, which means that my cloud computing provider will not tell me that I have to use at least 100 servers, um, and I have to pay for at least 100 servers per month. It's not like that. I can just go to Amazon Web Services and pay for start using a small server, very small server, $10 a month and something like that. Yeah, Pim. I think the blame also comes with the job, I guess. uh, okay, and then yeah, there's zero monthly usage commitment, zero minimum use, and all this is especially true of all the AWS services, which we'll talk about. Okay, then another thing I wanted to note is that cloud computing brings natural economies of scale. Okay, so think about we were building a 100 server database, sorry, 100 server data center. But let's say instead of 100 servers, if we wanted to put 100,000 servers, then what I can do is that the a great amount of money that I'm spending, especially on the software, the software side of things, the administrators, the developers, things like that, that gets amortized over a large number of servers. So cloud computing naturally benefits from economies of scale. And I don't know if you're familiar with this term, economies of scale. It basically means that uh, if you have more number of units, your per unit cost becomes lower. So let's say with only 10 units, your per unit cost is, let's say, $100. But if you have 10,000 units, your per unit cost may be only $10. So does this make sense? And this is also why we see that uh, because of the economies of scale that AWS has been able to get because of its size. This helps it invest a lot into adding more capabilities and in innovating. Okay, and then I just want to talk about one term, moving to the cloud. So when you see if somebody is saying moving to the cloud, this it typically means that the organization is moving away from a traditional CapEx model where they would buy dedicated hardware to the OpEx model where they would use a shared infrastructure and pay as you go. Okay, so Pim is saying that this is basic, economic, and boring. Okay, so let me answer that. So I think so cloud computing, at least to me, is not just a technology. It is a business model. It is an economic model as well. Uh, because essentially, I mean, see, today your boss is paying you, but don't you want to be the boss yourself? And if you want to be, these are the things that we have to understand. That what is the benefit of cloud to a business? To my business. What is the benefit of cloud to my business? Why should I move to the cloud? And so it's not just the technical side of things. It's also the economic model and the business model is very deeply integrated into the cloud computing concept. Okay, so surprise thing is no more IT, it's BT. What is BT? Is business technology? I don't know. I don't know what BT is. Okay, right. So that's what I think. Okay, now talking about something more on the technology side of things. So there's something called different shapes of the cloud, and I will be sharing one article with you which talks in much more detail about this. But essentially, till now we've talked only about the first two items on this slide. The software as a service and utility grid. So we've seen that how there's a trend towards software as a service because it is software as a service is more convenient for customers. So customers are driving the trend towards software as a service, and because of that, software as a service is driving a trend towards consolidation of IT. And then there's this model called utility grid, pay as you go utility subscription based computing resources, which is driving towards cloud computing. But there are two other very big shapes of the cloud, and basically shapes of the cloud means the use cases for the cloud. That's what it means. So another one is data center. So what has happened till now is that companies like AWS, Rackspace, these have come up, and they have most of the adopters of these companies early on were either individuals or small companies. It was not really enterprise because of bunch of reasons. But now what is happening? So the question is, enterprises are asking themselves that how do we also need cloud computing, because let's say I think many of you work at IBM. So IBM has hundreds of thousands of employees worldwide, and IBM's employees, let's say, want to use they have the need for quickly provisioning 10 servers for some testing, or so they themselves have this need to use or get the benefit of cloud computing, quick provisioning, pay as you go, reduce capex. So they want all these benefits in the context of working in their own company. And because of this, there's this move to build data centers using cloud computing technology. And here there are these software or not software, I'll say a framework, like three of them are very popular: OpenStack, CloudStack, and Eucalyptus. And all these the modern data centers are now being built using these cloud software, and basically these frameworks, they help you build your own cloud on top of commodity storage. So you can go out, buy a rack of hardware, commodity, in terms of servers, storage, everything. Then put an operating system like Linux or Windows on that, and then build a huge data center based on this commodity hardware and software. And these frameworks help you manage that huge data center in a way that it's much cheaper and easier to manage than if you were doing it in a more traditional way. Then, and the other use case where cloud computing is gaining a lot of traction is distributed computing, especially in the context of big data analytics. So you may have heard of something called Hadoop, which is a framework to run to manage data and computing on big data at a large scale, at a distributed scale. And a lot of these Hadoop related use cases or big data use cases are getting run on the cloud, because they need these use cases typically involve running hundreds of thousands of servers, and then you need them for 2 hours, and then you don't need them for another few days. So it has that you don't always need to have these servers on at all the time. So you need this the attributes of cloud computing are really beneficial for those kind of use cases. Okay, so I think that are some use cases of the cloud. And then what are the obstacles to cloud computing? So one is network bandwidth, because what's now happening is that with cloud computing, my data is sitting remotely. So it's not, let's say I'm working at IBM. So in the traditional model, the data center would be maybe in the same office, or maybe maybe a few miles from my office. But with cloud computing, the my data is remote, which means that I have to access it over a wide area network, and that is a technology challenge. The biggest concern, I think, as some of you mentioned earlier, is privacy and security, and some of this is technical. Yeah, some of this is technical, and some of it is a mindset. So technical in the sense that, so think about Google. Okay, so Google has, or Facebook, they have a lot of our private data, and because of the scale that they are operating at, so they are operating at millions of users. If there's a security exploit in Google's or Facebook's network, it can potentially impact millions of users. Versus, if there was a small data center, for only 100 users, so even if there was a security exploit in that data center, it will affect only 100 users. So because of the scale at which cloud computing operates, any vulnerability, bug, exploit, security hole, it gets magnified very greatly. The second one is mindset. So especially in enterprises, there is this mindset that I don't have control over my data, or uh, so there's this classical there's this classic use case that people talk about, is that let's say I work for Coke, and okay, so I think so what if Coke, and the biggest the access for Coke is the secret formula, and what if my Coke servers are running on the same machine as Pepsi server? So what if there was some kind of bug because of which my secret can get lost or stolen, things like that. So it's more of a mindset issue. Uh, Even though the big the data centers of these cloud computing companies are way more technologically advanced and way more secure than data centers of other companies. Then okay, so I'm getting a request for a break. Okay, so I think we'll just finish this slide, and then we can take a quick 5 minute break. Okay, then there are these challenges like vendor lock-in. So this is like very similar to other enterprise software challenges. So once I start using Amazon Web Services, the problem is it's very difficult for me to migrate to Rackspace because they use very different technology. Uh, then service availability and business continuity. So there's always this fear that it's in some cases it's a well founded fear that there could be an outage in these cloud computing data centers, which makes my application unavailable. So for example, there was a big outage in the Amazon's data center in on Christmas Day of 2012, and because of that, Netflix was completely down, or down for a lot of its customers for on Christmas Day, and which is a day where a lot of people sit together with their families and watch a movie. And then yeah, another one is performance unpredictability. So what's happening, because in cloud computing we see that essentially we are sitting on we are using shared infrastructure which is used by other companies, other people that we don't have any control over. So what if those people, because of the shared environment, my performance is bad or unpredictable. So think of this, like let's say I have a shared network, and I'm sharing this resource with another company, and that company is hogging the network. So because they're hogging the network, my performance can go down. So these are some of the obstacles to cloud computing, and I think yeah. So is it okay? Can we take a 5 minute break now? Okay, so we'll take a 5 minute break now. It's 4:23 on my clock. So we'll meet exactly in 5 minutes at 4:28. Okay, no more than 5 minutes. Just very short, quick break. Okay, we'll get started again. So can you hear me? Can someone just give me a confirmation on the chat? Can you hear me? Okay. So no, we'll go a little deeper now. We'll go on behind. So there's three cloud service models: infrastructure as a service, platform as a service, and software as a service. I'm gonna quickly talk about what these are. So this is the application stack typically. So at the bottom there is hardware. On top of that there is operating system. On top of that there is some kind of a framework or a set of system software like database, um, application development framework, um, things like that. Okay, and on top of this framework we develop the application. Now let's look at these three different cloud models in the context of this application model. So if a vendor gives you the entire application, now for example Gmail, uh, so then that's called software as a service, because so this is we are looking at this from a users or customers point of view. So if somebody is giving me the entire application, then I'm basically a user of the application, and this is called software as a service. And typical examples of this are Gmail, Facebook. So any kind of application that we use as an end user. Now, if somebody is on the other hand, if somebody is giving me only the hardware and the operating system, then it's called infrastructure as a service. And this is the main business or main thing that Amazon Web Services does. And on top of this, so basically I get a server which is essentially hardware and an operating system, and on top of that I have to manage everything. So I have to manage the database server, the web server, um, the application framework, and then on top of that I have to write the application also. So in that case, what I'm getting is infrastructure as a service, and in the middle there is something called platform as a service, where we get kind of a complete platform on which we can write an application. So examples of this are common examples of this are Salesforce.com or the Force.com framework, or Google App Engine, Heroku. So on these services, what we need to do is just we need to write the core application logic. So let's say I'm developing some financial accounting application that will help accountants do their work better. So I just need the domain knowledge and the programming knowledge to build the application, and everything else is taken care of by the platform as a service. And everything else means there is some kind of a framework that will help me save my data to the database, will help me back up my data, will help me serve the data using a web server, so things like that. Okay, we see as Uh, so just can you just remind me of VPS? What is the full form of VPS? The scalability and inbuilt feature of PaaS are not necessary, but it can be. So, for example, on Heroku, what we can do is we can easily configure that how many servers do I need. Will I, do I need uh, 2 servers or 10 servers? And but I do have to configure that. So it is like it can be a feature of the platform as a service. Just one second. So Ankit is asking, what's the difference between a platform and a framework and a application? So see, application means let's take an example. So let's say I'm writing an financial accounting application. So the main application will involve the core logic of what the application does, but to serve that application, there are a lot of other things required. So I need, let's say, a database. I need a database to store that data. I need a web server to serve that data to my users. Then I need that data to be backed up. Then there are more value added things like instead of talking directly to the database using a low level API, we can have a so for example, Salesforce.com gives you a graphical interface to the database. So all those are value added features on top of the on top of low level technology, and that become a framework. And there are lots of different kind of frameworks out there. So VPS is essentially a virtual private server, and it's essentially a virtual machine. And what we'll see is that the virtual machine or VPS is a key building block uh, in building a cloud or in cloud computing. But a VPS is not. So what do you call VPS and infrastructure service? Yes. So a VPS is an infrastructure as a service, because in that you only get the lowest two levels of some hardware, which is CPU, memory, hard disk, and on top of that you can have some operating system which is installed by the service provider. So it is infrastructure as a service. Okay. Any other questions on this? Uh, okay. Any other questions on infrastructure as a service or platform as a service? And also another way to think about it is in terms of the user. So if you are the end user of an application, typically that would be a software as a service model. Or if you are an application developer and low level things like database, web server are taken care of, then it's it's likely to be a platform as a service model. And on the other hand, if you are if you are working at a low level and you have to be responsible for writing your core application logic, as well as you are dealing with things like backing up your database, managing your database, things like that, and managing your web server, managing the scalability. So then it will be a infrastructure as a service model. Okay. Then there are let's talk about the different deployment models for the cloud. So there's public cloud, private cloud, hybrid cloud. So in public cloud, essentially uh, all these these services are rendered and they are open for public use. So public use means anybody can just go and use those services. So there's yeah, basically anybody can go and use those services. Versus in private cloud, it is typically for um, businesses, where it is either for a single, it is typically for a single organization, and the cloud is there. The private cloud is physically separated uh, from another organization cloud, and this the cloud or the data center to be managed by either the organization itself or a third party organization, and it can also be hosted internally within the organization, or be hosted externally at a hosting provider. But the key thing is that the interest in a private cloud, the it is for a single organization, and there's a physical separation between the clouds of two different organizations. So even if, let's say, for example, T Systems is a big provider of private clouds, and they provide private clouds to other companies, and their data centers have a physical separation between the servers of one company and another company. Then there is hybrid cloud. So this is where a company is using both a combination of private cloud and public cloud, and a typical use case of this is something called cloud bursting. So in cloud bursting, what happens is that my application is running in my data center or in my private cloud, but when there's extra load on the application, I I will rent some servers from a public cloud provider such as Amazon Web Services for a short amount of time. And so for that short amount of time, the application is partly running on my private cloud and partly running on a public cloud. Then another example of hybrid cloud is when for data backup. For example, a lot of the times data applications are running on a private cloud, but they are backed up on a public cloud like Amazon, and so that also becomes a example of hybrid cloud. Okay, let's quickly talk about what are the key enabling technologies for cloud. So essentially, I thought there are three technologies. One is server virtualization, storage virtualization, and then internet bandwidth and latency. So let's talk about quickly about these. So virtualization essentially means the separation of a logical entity from the underlying physical entity. So for example, server virtualization, what happens is that let's say you had 20 small servers, which was physically different machines, they had different hardware. With server virtualization, what you can do is you can buy a one big server, with more memory, more CPU, and then put those 20 servers as logical entities on this one physical server. So this is by this we are reducing our physical footprint, and we are moving from 20 logical instances on 20 physical instances to 20 logical instances on one physical instance. Okay, and essentially this is an internal view of server virtualization. This is a diagram from VMware, which is one of the leaders in server virtualization. But note that Amazon does not use VMware. Amazon uses something called the Zen virtualization. And essentially, there's a virtualization layer just above the hardware, and that virtualization layer presents a virtualized view of the hardware to the guest operating systems. So then on that virtualized that virtualization layer, we can run n number of operating systems, and these n operating systems will not be dealing directly with the hardware. Instead, they will deal with the hardware through the virtualization layer. So any questions on server virtualization? Okay. Then server is from Citrix. Yes, it is. So I don't know if it's from Citrix, because Zen is an open source project, but definitely Citrix is one of the big backers of Zen. Yes, AWS uses Zen virtualization, but AWS, because of this, they have their own, they have their own large scale requirements, so they have heavily customized the Zen uh, the Zen virtualization layer. Okay, better to explain the IBM virtual machine slash VM slash SP. What does VM and SP mean, Tim? Is it virtual machine? Okay, I think so Tim, you can just clarify that question and we'll come back to it. Okay, then similar to server virtualization, there's storage virtualization. Um, which here we have, instead of virtualizing the CPU and memory, we are virtualizing disk. So what happens is that let's say so traditionally you would have let's say you had 5 disks. These 5 disks would can be collected together to present one logical storage instance. Okay, but with storage virtualization, you can collect these a large number of disks together and put many logical storage instances on that on a collection of disks. So this is beneficial because let's say for a disks are becoming bigger. So nowadays disks are 1 terabyte to 3 terabyte kind of capacity. But what if I need only a small amount of disk or storage? I just need 100 gigabytes or even less. So it's important to be able to carve out a small piece from a large piece, and then what I may also want to do is that I want to start out with 100 gigs, but I want to increase it to 200 gigs maybe a month later. So all these kind of features can be implemented if the storage is also virtualized. So I'm not going to be talking about a lot of these server virtualization features, but I am sharing a reading article from VMware on server virtualization, which talks about some of the awesome features that the cool things we can do with server virtualization. And for example, one of these things is live migration. So in live migration, we can move a complete a logical instance of basically a virtual machine. We can move it from one physical hardware to another physical hardware, or we can increase the capacity of the virtual machine without even shutting it down. So server virtualization technologies have come a long way now, and you can do really cool things if because of server virtualization, storage virtualization. Okay, and I think with that we are at the end of this module. There are a lot of articles I'm sharing on this related to cloud computing. You know, some of the trends that have led to cloud computing, the different kinds of cloud computing like infrastructure as a service, platform as a service, then virtualization. So please go through these readings because they'll give you a much better understanding of what is cloud computing and why why we are uh, why is the industry adopting it at such a fast rate. And you will also have assignments on based on these reading materials that I'll talk about later. Yeah, links will be shared on the LNS. So we have not yet set that up. So I'll set it up after this class and share it with you. Okay, let me just check. Yeah, so this is just a summary of what we discussed. And with that, yeah, thank you for your patience with this module. And we'll go on to the next one. Okay, I'm glad, Tim, that it was getting interesting and not more boring. So what we'll do, I think we have another 20-25 minutes. So I'll just give a quick introduction to AWS in maybe 10 minutes, and then I want to give you a quick walkthrough through the AWS console. So we will just go quickly, a little quicker through the slides because a lot of this I've already been talking about. So what is Amazon Web Services? So it is a global scale cloud computing provider, and so global scale means that it's present in several locations in the world, as well as it is the biggest. It has the largest scale, so it kind of gives a illusion of infinite scale. We can go and quickly create within 5 minutes. We can create 100 machines on Amazon Web Services without any dent on it. And AWS is primarily an infrastructure as a service provider, which means it basically gives you a you know a hardware and operating system on top of that. And if you want to do whatever you want to do above that, which is basically your application related stuff, you have to do yourself. So a corollary of this is that using AWS is not very easy. So because it's dealing at a low level, a lot of the things have to be done. A lot of things that an IT administrator has to do still need to be done in Amazon Web Services, and which is where people like us come in. And we will of course during this course we will talk a lot about what are the kind of things application developers and more importantly administrators what are the kind of things we can do on AWS. Does that mean we have to install the platform? Okay, what do you mean by platform, Ranjan? Give me an example. Java, yes. So either Java should be bundled into your image, the virtual machine image, or if it's not bundled in, you'll have to install it yourself. Okay. I think I've already spoken about the third point. AWS offers a self-service model where anyone with a reasonable amount of technical expertise can deploy the application. So this is it's both true and not, because many people do find the people who are not really technologically inclined, they still find AWS very hard to work with, because AWS is still it's at a quite a low level, and you still need quite a bit of IT skills to be able to let's say deploy an application on it. Okay, AWS is the biggest cloud computing provider, and that's why we're talking about it. Estimates. So we don't know what is the market share AWS has. We don't know how much revenue they are making. There are only guesses to go by. And but the guesses are that AWS share in cloud computing market is more than 60 to 70%. So it's like uh, it's the number one by far. And because of this scale, AWS is able to innovate faster in terms of offering more value-added features, and as well as offer lower prices, because this goes back to our discussion on economies of scale. If you have more scale, you can offer cheaper, you can work at cheaper, you have lower cost, and because of the lower cost, you can offer lower prices to your customers. So, Sarfaraz, is it more simple or complex or simpler to manage AWS than self-hosted? So the answer is it's it's equal. And by self-hosted, I assume you mean a somebody who's giving you a virtual machine. Like if you're familiar with sites like Linode, um, but so AWS is significantly more complex than a platform as a service. But at the same time, it's also much more powerful, because there's always this trade-off between flexibility and power versus ease of use. So what is more flexible tends to be harder to use, because it gives you more number of options, and then you need expertise to handle those more number of options. So AWS is more flexible than Salesforce and Heroku, but it is more hard. Because of that flexibility, it's much more harder to use as well. Yes, you get internet connectivity on the virtual machines created. In fact, I want to do that in a few minutes, so that yeah, you can install any custom software. Okay. Uh, so the AWS is the most innovative, and it's kind of the ringleader for cloud computing. It's because of AWS that uh, especially a lot of startups have benefited by AWS, and in fact, I feel that the startups have been the biggest beneficiaries because of AWS. A point in case is Dropbox. I'm sure that many of you know Dropbox. It's complete. It would have been impossible for a service like Dropbox to scale if they had to build their own data centers. So a service like Dropbox, they just add innovation in the software, and they use AWS for the for all their infrastructure requirements. And the same is true for the upcoming company from India called Dhruva. So it's a Pune-based company which is doing a lot of good software work in the backup area. Yeah. So this class would have not been needed if it was simpler. Uh, Eucalyptus is open source, then why it is okay? So with Eucalyptus, it is just software. It is a framework or a software uh, that you actually have to deploy to build your own cloud. So it's not an offering where I can go and say that I want 10 virtual machines. No, it's just software. Whereas AWS, you just go there and tell it that I want 10 virtual machines, and you get it. So basically, Eucalyptus is just software that can be used to build a cloud. Again, the global scale at AWS is also allows it to hire the best people, and that's why they keep on adding a lot of cool features. Okay, there are three ways to access and manage all of AWS's services, and we'll talk about what these services are. Uh, there's the GUI console, there's the command line interface, and then there are the API. And again, the first one is the easiest to use but the least powerful, and APIs are the hardest to use but the most powerful because you can start scripting them. Okay, I think another thing I want to talk here is another trend in terms of the infrastructure management. So what's happening is here's a question for you. So do you think that someone can manage someone, let's say we have a data center of 10 servers and we have a data center of 1000 servers. So do you think they can be managed in the same way? A data center of 10 servers versus a data center of 100 servers, 1000 servers. Surface, the company name is Dhruva. I'll just type it out. So how would you manage 10 servers? Okay, but Tim, I think you come from a system administration background, so I think you know better than all of us that things go wrong. Hardware fails, software has bugs, software fails, things like that. Then there need to be routine tasks like patch upgrades, provisioning new servers, provisioning new software, things like that. So, and okay. So, do you think there's a difference in provisioning 10 servers versus provisioning 1000 servers? There's a great difference of scale, right? Yeah. So, okay, you create a golden copy, but then still you have to patch it, right? When the software is upgraded, you still have to patch it. And with 10 servers, you could probably go physically to each of the servers and insert a CD and do it. But with 1000 servers, you can't. For example, it all has to be done remotely. But the main the kind of the point I'm coming to is that the cloud computing is driving towards there's this trend towards consolidation of infrastructure, computing resources because of SaaS, which is driving towards larger data centers. There are more SaaS applications getting built, which means you need larger data centers to serve those applications and things like that. And you can't manage a large data center in the same way that you can manage a small data center. You need much more automation. You need much more automation in every area. Basically every task should be automated, especially at AWS scale. So these guys are managing something like 50,000 or at least like hundreds of thousands of physical servers, and each of those physical servers will have maybe 10 to 20 virtual machines. So they're managing millions of virtual machines. Plus they have this is just virtual machine. There is storage. There are a lot of other features, and this is driving a trend in systems administration called DevOps or SysOps, which is basically that the amount of automation in your systems administration has gone up. So every systems administration task has to be automated and automated properly. It's not like earlier there could be bash scripts or Perl scripts that are automated, and many times they may not even be they may not even be source revision control, things like that. So all those things cannot be done now. Now it's like there's a lot of component, there's a lot of development kind of tasks in systems operations, uh, and this automation is done using API. So we will not be talking about AWS APIs in detail here, but if you need to be able to manage a big setup. So for example, if you are just managing maybe 10-20 servers or maybe 50 servers on AWS, you can do it using the console. Beyond that, maybe maybe 100 servers or something, you can do it over the CLI. But even beyond that, then you need to be able to use the APIs also. So as systems administrators, this is like a trend in the industry, and if you if you know how to use APIs, and APIs are basically it means that you need to know programming. You need to know programming in a scripting language like Python or Ruby, or maybe in language like Java. So so traditionally systems administrators did not need to know programming. And if a systems administrator knew Bash script or Perl script, that was great. But now you have to be able to program using these APIs, and so that's something for you to think about. If you don't know programming in these scripting languages, that's an area that you may want to invest in. Okay, so AWS has 9 regions worldwide. They have 3 in the US, 1 in Europe. So North Virginia is the first and oldest and biggest data center. Then they have 2 data centers in Asia, Singapore and Tokyo, 1 in South America and 1 in Sydney. And why do a question, why does AWS have 9 regions? Why do they have these regions spread across the world? VR. Okay, and any other answers? Business continuity process. Okay, data proximity. What does that mean? Why is data proximity important? Low latency. So see, if I'm a user sitting in India, and if I'm accessing an application over the internet, the latency is very important to me. So if the server is in Singapore versus if the server is in US, there can be a significant difference in the latency, which impacts the usability of the application. Because okay, let's say when you're doing Facebook, so you do something on Facebook, you want it to get back to you immediately. You don't want to wait for 2-3 seconds for that to happen. So so to serve customers worldwide, that's why AWS has regions across the world. Okay, and we'll talk about pricing later. Okay, there's a concept called availability zones. So every region has multiple availability zones, which essentially every availability zone is one separate data center. So so for example, a region could have a region could have 3 availability zones, and the main point about these availability zones is that they are distinct data centers, so they have distinct power sources, power backup sources, networking is distinct, and so on. So these availability zones can be used to implement what's called high availability for your application. And high availability essentially means that there's no single point of failure in the application. And we'll see later on in the course how to do this. But essentially the idea is that you put, let's say you're deploying an application, you put some of your servers in availability zone 1 and some of your servers in availability zone number 2. So if a failure happens, what Amazon guarantees you is that unless there's a natural catastrophe like a flood or an earthquake, unless it's something like that. What Amazon, because what the availability zone architecture guarantees you is that two data centers or two availability zones will not fail at the same time. At least one will be operational. So, for example, if there's a power failure, uh, you know, there's a good chance that will affect only one availability zone. Okay, so we have talked about I think we've covered at a high level what is AWS, regions, availability zones, a pricing model. Essentially, we didn't cover in detail, but it's pay as you go that we talked about. There's no upfront fees for any of AWS services. Although, that said, it's relevant to note that they have different pricing models, and if you're ready to pay an upfront fee, your usage fee goes down. And okay, yeah. So with that, uh, let's take a quick dive into the AWS console. So by the way, this is uh, the Amazon Web Services homepage. So the URL is aws.amazon.com, and this is a great reference for a great amount of information. Though a lot of the information tends to be very very technical, and it's not always easy to understand for somebody who doesn't have uh, a lot of the technology background, and which is good for people like us, because people with technology background are required to use AWS. So on that, so what I did, okay, one second, let me just log out. Okay, so I'm going to go back to the AWS homepage, and on this right side there is this AWS management console. So click there. Okay. Just a second, let me just try to get my password. Okay, and till the time I'm doing that, so AWS has a free tier which gives you access to one virtual machine for 1 year. Plus, it also gives you free some amount of storage and some amount of network usage. It gives you free, so you can use uh, you can use the free tier, and you can sign up for the free tier, but you will need a credit card to create your own account, and uh, but AWS will not charge you on that credit card as long as you remain within the free limits. In fact, let me just show you. You go to this page, and so if you just there's this big button, get started for free. So you can use this to create your own account. Okay, I think it's for me it's going to my account. And but if you don't want to create your own account, what we'll be doing in this course is I'll be giving you access to my account. So each one of you will have a login to AWS, essentially on my account. So you can use it, but please don't misuse it. And yes, I've got my password. Okay, so I'm just going to go to management console. Okay, so this is the management console, and uh, it's so as you can see there are about I think more than 20 services that AWS offers, and each of these can be managed at least to some extent through this console. And AWS has segmented these services into what I think 6 categories: compute and networking, storage and content delivery, database, deployment and management, analytics, uh, and app services. Okay. So what I'll do, I'll quickly give you a demo for the basic service, the VPS service or the virtual machine service in Amazon, which is called EC2. Okay, so I click on EC2, and EC2 stands for Elastic Compute Cloud. It's essentially a pay as you can create virtual machines on EC2 and install your own applications on that. So what I'm going to do, I'm going to create an EC2 machine, and it's called, in the AWS terminology, it's called an instance. So I'm going to create an instance, and through that process I'm going to introduce some of the EC2 concepts. You'll also have an assignment on creating your own EC2 instance and deploying a simple application of your choice on that instance. Okay, a quick question here: how many, what kind of operating systems do you typically work with? Who are the people who typically work on Linux, and who work only on Windows? Yeah, so can everyone reply? Is there somebody, any of you who work only on Windows? Okay, Avinash and Hidayat, do you work only on Windows or like a combination, and Ankit as well? Okay, so fine. There are a couple of differences, uh, in terms of logging into Linux instance versus a Windows instance, and we'll try to understand those. Okay, but this is the home page, and we'll get into basically launching an instance. Okay, so basically I'll be creating a virtual machine. So to create a virtual machine, I need the image uh, that the virtual machine will run, and in Amazon terminology, it's called an AMI, or Amazon Machine Image. Okay, so step one of creating your own instance is to select your AMI, and you can see on this page, these are the Linux options. So Amazon has its own version of Linux, which comes with the a bunch of, like, these softwares pre-installed. Then there is a Red Hat Enterprise Linux. Then there is a SUSE Linux. Then there is Ubuntu, which I'll be using. I'll be using Ubuntu 12.04. And on the right side, you can also see there is 64-bit and 32-bit version. Yeah, they are pre-configured. So I won't call them an ISO image. They are like these are the Zen images that are pre-configured to launch a new Zen instance. Okay, free tier is it gives you one micro machine free for 1 year. Well, I'll send you the link. I'll send all of you the link to the free tier, and I think it'll be better if you go through it offline. So these are there are so you can see there are so many pre-configured AMI images, and same for similarly for Windows. Now for Windows, what you see is all these are Windows servers. So Windows Server 2012, Windows Server with SQL Server, and right. So one question to you: how do you think Amazon will be charging for the Windows server license? It is inclusive, but how can it be inclusive? So typically Windows software, there's an upfront fee, right? You typically pay whatever depending on your Windows server, you know 300 $3,000, something you'll have to pay. Yeah. So essentially there's some kind of agreement between Amazon and all these software providers where uh, the charge for the software is built into the per hour. So what we'll see is actually all these machines are charged on a per hour basis. So the charge for all these softwares are built into the per hour charge. So for example, Linux will definitely be cheaper than Windows, because in Linux there is no let's say for Ubuntu Linux or Amazon Linux, there is no licensing fee for the operating system, and Windows will be more expensive, and there will also be like Windows server base will be cheaper than Windows server with SQL server. Okay, I hope it makes sense. Um, okay, so I'll just select Ubuntu. Okay, where is Ubuntu? Okay, I'll select that. Okay, now the instance type, which is basically this is Amazon is asking me what size of virtual machine do you want to create, and in terms of size, it's the computing power, how much CPU, how much memory, and here Amazon comes with some 10-15 sizes are there, but they are all pre-configured sizes. So for example, micro has up to 2 ECUs. So we'll talk about what is an ECU tomorrow, but it is essentially a measure of the CPU power, and it has 613 MB of RAM, and storage. We will talk about storage later. Then in the general purpose tab, there are these other images, other instance types. So small, medium, large. So basically they have the same ratio of they kind of they are almost like double. They have the same ratio of compute and memory. Okay, now the account that I will give you is I have some access restrictions on the account that I'm going to give you, where you will be only able to create micro and small instances. and this is to protect me that that I don't run up a great bill at the end of this course. So please, you know, uh, no, I think I've set it up correctly, and you will not be able to create anything except micro and small. But even if you do, please let me know, because otherwise, I'll get a shock at the end of the month. Okay, and there are more instances. Memory optimized means they'll have more memory versus CPU. Then compute optimized means they have more CPU relative to the memory, and storage optimized means they have some special storage. So for example, this one has SSD storage, so solid state disks, flash, essentially flash storage, and all the others have disk storage. So anyway, what we're gonna do, we're gonna select micro. So I just click on micro and I go to the next step. So here I can say number of instances. So see, let me just create two. So I'm gonna create two instances in one shot. Hot instances, we'll talk about this tomorrow. Then VPC also will talk about tomorrow. Availability zones. Okay, so okay, I think I forgot to talk about one thing. So if you look at the top right of the window, can you see here North Virginia, right? So this is the region that we are operating in. So currently we are operating in North Virginia region, and I really don't like this interface, because this means that so now I'm in North Virginia and I cannot there's no option for me to select a region. It's like this, whatever you're doing is in the context of context of a particular region. So anyways, now North Virginia, the short name for North Virginia is US East 1, and there are 3 availability zones in this region: 1A, 1B, and 1D. I think C is I think full or something like that. But basically there are 3: A, B, and D. Now with so I have to select. Do I have any preference for an availability zone, or I can just say no preference. Now you may have a preference. So for example, you may want for whatever reasons you may want all of your machines to be in the same availability zone. So in that case, you can pick a particular one. Now, one point to note about availability zones, which is a little tricky, is that the availability zones that I see are not the availability zones that another account will see. It basically means that so let's say the availability, there are 3 availability zones, 1, 2, and 3. So for me, it could happen that 1 means A, 2 means B, and 3 means D. But for another account, it could be that 1 means B, 2 means A, and 3 means D. So that mapping of these letters A, B, and D to the availability, to the exact data center are different for different accounts. And so this is how it is. Okay, this shutdown behavior is saying that when I shut down the machine, by default, do I want it to stop or do I want it to terminate? So stop means that the machine will just stop and I can restart it after some time, and terminate means that the machine will be completely destroyed. So by default it stops. Enabled termination protection is some kind of a protection against accidental termination, and monitoring using CloudWatch. We'll talk about that later. And these are typically, I don't ever need to change this. The kernel ID, RAM disk ID, I never need to change this. Okay, next is we're going to add storage. So by default, uh, so this has 8 GB of storage, and I can just change the number here. 10. Um, there's a kind of storage called provisioned IOP, which we'll talk about tomorrow. Okay, delete on termination. So delete on termination means that what happens to the storage once this machine is deleted. So if this is checked, it means that if the machine is if this virtual machine instance is deleted, the storage that is attached to this is also going to be deleted. Otherwise, you'll have the storage there with you even after the machine is deleted, and you can use it for some other machine. Okay, the other thing I can do is add new volume uh, to this machine. So let's say I'm going to add a small volume of 2 GB, and okay, I'm going to set it delete on termination is false for this one. Okay. Right. Then on this step you can tag these machines. So here's a request for you guys that when please name these machines that you're using so that we can easily identify that these are your machines, because otherwise I don't think there's any way to figure out that whether this machine has been created by Aditya or by Avinash. We can't figure it out. So if let's say if Aditya is creating this machine, put in your name there in the value, and for me, so this is a test user, I'll just say test01, and this is I'll just say test01 is the name of the machine. Okay, now this is a very important step, configuring the security group. So security group is the Amazon name for firewall rules, essentially. And so what is going here is I'm going to create a new security group, and then these are the firewall rules for that security group. So SSH, I want SSH, and this is the I can say protocol, TCP, port, and the source. So basically this line means that this machine will the port 22 will be open for from any IP address. Then I can also say I'm going to add a rule for HTTP. Sorry. The HTTP port 80 is also open. Okay. So this is basically security group means the set of firewall rules for the machine. And in this case, I am creating a new security group. I also have the option of selecting an old security group. So these are my previously created security group. I could have used them as well. One point to note here is that once you have assigned a particular security group to a machine, it is done. You can't basically, let's say if the currently launch wizard 5 will be assigned to the machine. So once this machine is created, you can't go and say that no, I don't want launch wizard 5, I want launch wizard 6 for this machine. You can't do that. What you can do is modify the security group anytime, even once the machine is created. Any questions or clarifications so far? Am I going too fast, or is this all making sense? Yes. So we can add delete rules and security group anytime. But we can't change the mapping of the security group to the machine. Once we have said that security group now, so and so is assigned to a machine, it will be assigned to that machine forever. Yeah, guys, the firewall is not in your. That's right. So this firewall is actually I'm not sure on that one. So I think the question Sam is asking is that this where is this firewall implemented? Is it uh, on the machine itself, or is it in the network of the networking layer of AWS? And I'm not sure, but I think it's on the network and not on the machine. So for example in Linux there are these IP tables is there. So I don't think this is the IP table firewall. I think this firewall is implemented in the AWS network, but I can check and get back. Using security group or IP table better. So what do you think? So definitely, this firewall is at a very basic level. Like for example, this doesn't have any state inspection. It's just very basic. It's just saying protocol, the transport protocol, which is TCP or whatever, and the port and the source IP address. It doesn't have uh, the advanced kind of inspection that IP tables can do. Secondly, this is just for incoming traffic. So for security reasons, you may want a firewall for outgoing traffic as well, and I don't think security group can do that. Okay, maybe done in VPC, right? So I think Abhi, so we can check it out. I think IP tables will be so I've never had to configure IP tables, which means that it's either off by default or it's allowing everything by default. So we can check it out once we have this machine up. Yes, okay. We can also have IP tables in addition to security groups. Okay, so let me just launch this machine. So if you launch, so just before launching, AWS tells me it just gives me the details of this machine I'm going to launch. So where we can just check that everything is okay, and then I say launch. Okay, last step. This is very important. So uh, so at least this Ubuntu machine doesn't support by default. It doesn't support logging in via an username and password, and this is for security reasons. Right. So whereas for example on Windows Azure, I was working on Windows Azure on also on Ubuntu. They have left the option of username password login open, so it's possible there. But in AWS, it's not possible. So the only for SSH, the only mechanism supported is via this public key and private key authentication. So for that we need to set up our keys before creating the machine. So it gives gives a couple of options. Either we can choose an existing key pair or create a new key pair, or proceed without the key pair, which could be that you can create the key pair later on. Yeah. So we can use SSL keygen uh, to have the keys. But in this case, what AWS will already set up the key pair for you on the machine. But we just have to say which key pair it is. So I already have a key pair created, and I've already downloaded this, and so I can I just go ahead and do that. Now the thing to note is, again I find it a little inconvenient, but once you create a key pair, this is the only time that AWS will allow you to download that key pair, basically the private key. And if you if you lose it or something like that, then that key is tracked. You cannot log in into any machine that was using that key. So please be careful. When you create your own machines and your own key pairs. So you will need to create your own key pairs, by the way, because if everybody's key pair would end up being different. Yeah, and so Tim, the thing is that I find it a little inconveniencing that Amazon doesn't allow any way to download the private key except when it's being created. The only time we can download it is so let's say I create a new key pair. This is the only time I can download it, and there's no other time. And that's the way it is. Okay? And that's why it has this cute little acknowledgement at the bottom that I acknowledge that I have access to the selected private key file, and that without this file I won't be able to log into my instance. No, we can't generate a new pair, because if we lose this key, the private key, we'll not be able to log in into the machine also. So I've launched that instance, and this it takes a minute or so. Okay, so what we'll do, we're going to click on view instances, which will take us to the instances. Yeah, so Tim, I don't think there's any way to add a key to an existing machine. At least I've not seen that. So we can see our two machines are creating. And in the meantime, let me go ahead and try to create a Windows machine as well. Here I'm going to use a small instance, because micro is too small for Windows. Windows takes more memory, so I'm actually going to use a small instance. Okay, all of these are same. I don't need to change anything here. Storage will have a default 30 GB volume. So again, we can add more tags also. We can add any number of tags with a basically key value pairs. These can help you manage your machine. So you may want to tag your machine saying that they are part of application one. You can tag it by application, or you can tag it by use case or purpose. Whatever you want. small instance is not in the free tier. Only micro instance is in the free tier. So good luck running Windows on micro, because it has micro has only 600 MB of RAM, and uh, Windows won't like that. Okay. Security group. So RDP. So Windows guys, I'm sure you know RDP. So for Linux it was SSH, and for Windows it's RDP. So can somebody please tell me what is RDP? Remote desktop, right? So that's the way to log in into a Windows machine. Okay. I think, uh, okay. So the warnings are okay. There's no problem here, and I think I can go ahead and launch my machine. And I'll use the same key pair. We'll be able to use the same key pair. Okay. Okay. So guys, okay, we are over time, but I think we'll be done in another definitely in another 5 minutes for Linux, and maybe in another 5 minutes for Windows. Okay. So our um, this machine is up, right? Then up one, at least one of them is up, and the second one is running, but the status checks are initialized. Okay, so we can just quickly go over this, go over this list. So this is the name of the machine, which I can, I can go and change the name of the machine. So I can say this is test 101, this is number 2. So this is where you should put your name. Okay, at least I should be able to identify whose machine it is. Then the instance ID. This is like a unique ID by which you can identify your machine, and this ID is going, can be used in the CLIs and APIs. The instance type, which is essentially the size of the machine. The availability zone, the status, or the the current state of the machine which is running. Status check. So when Amazon, whenever a machine restarts, there are certain checks that Amazon does on the machine. Things like, is the machine up properly? Does it have network access? Things like that. Alarm. We are going to talk about this later. And then I think there was a question around whether a machine has public address or not. So a machine has a public DNS address, and also a public IP address, and also a private IP address. And we are going to talk about this tomorrow. But uh, for now, we will use the public DNS. This is the public DNS for the machine to access it. Okay, and IPv6. So I think some machines may have IPv6 uh, support, but I've always used IPv4. So I'm not actually sure if Amazon to what extent it supports IPv6. Okay, and then you can go over it. We'll be talking about some of these things tomorrow. But for now, I just copy this public DNS. Now the only thing, okay, there's something I wanted to tell you about IP addresses, but we'll do that tomorrow. So let me just go and use this machine. Okay. So I hope you guys can see my Ubuntu. This is my Ubuntu running on my laptop. This is also running as a virtual machine actually on top of my Windows. Okay. So the thing that I have to do is one- so let me copy. I need two things. Okay, I need the DNS for the machine. For some reason, this is, yeah, got it. And I need the private key. Okay, so the private key I have downloaded. Um, this one. Okay, and let me just copy the so this is my the private key file, and what I do, we just have to do in SSH. If you're familiar with SSH, um, I may have to, let me just check. I may have to, uh, yeah, I need to tighten the permission on this one. It's not a root key. This is it's actually the key for the user Ubuntu, which we'll see. Okay, all of you seen this command? It's ssh minus I, basically which is the identity file, the private key file, and then Ubuntu at the machine IP. Okay, and so now we are in the machine. This machine is by default it's running this Ubuntu. I think this management software something. But anyways, we are in the machine. Uh, so this is what the machine looks like, and just yeah. So I'm the so this is the Ubuntu user, and yeah. Now basically we can do anything on this machine, like we can install any software and things like that. Okay. Yeah. We wanted to check IP tables, right? So we'll just check that. Okay, so I need to do this as sudo. So you can see the IP tables are empty. So this confirms that the security groups are not implemented as the host firewall. They implemented in the in the AWS's routing and network itself. Okay, so with this, I think let's close today. Um, but yeah, I wanted to show you this one thing. Just one last couple of minutes I need. Yeah. So this is your assignment. Uh, so firstly, the first thing is that you have to go through all the reading materials. I think I highly suggest you to go through those articles, at least briefly. Then the assignment has 3 questions. So number one, so you have to write a short article on the latest technology trends in cloud computing. So please search on the internet, read articles, collect information, find out some of the latest technology trends in cloud computing, and could be in any of those 4 shapes that we saw. Could be software as a service, could be utility computing, could be data centers, could be private cloud, could be this distributed computing using Hadoop and things like that. But I want a short article, could be I think less than 300 words on some of the latest technology trends in cloud computing. Okay, and post this in some public medium. Could be a blog, Facebook, Google Plus, somewhere. Any public website, and you need to submit a link to this article on the LMS. It's not an essay. It's a short. Think of it like just you're kind of explaining the latest technology trends to someone, and the purpose of these articles, these assignments is to make sure that you put in a little bit of effort to understand the subject, because I told you upfront, and I'm going to repeat it, is that the time that I'm spending in front of you explaining these concepts is probably the least valuable thing we are doing in this course. The most valuable thing will be when you yourself put in the effort to understand the subject, because that is how you will actually get to explore and learn things on your own. So please do this. Then write a short article on comparison, comparison or understanding of IAS, PAS, and SAS. But also I'm kind of flexible on these articles. If you like, for example, if you want to do versus public cloud versus private cloud, do that, no problem. Basically, I want you guys to pick up some topic, and write a short article explaining that, or understanding that topic on your own. Okay, and again, this needs to be a public hosted on public website. And the third one is something that we did. I'm just going to change this a little bit. So let's say you're going to run n servers, some number of servers for for your company, for your application, for 3 years. So I want you to list down all the items against which you will incur costs. So all the heads that we have already listed. Then I want you to put some value to those to that cost. Like assume some cost for the hardware, some cost for the manpower, some cost for the real estate, things like that. Whatever heads you come up with, assume some cost for it, and then tell me how much does it cost to run this on your own for 3 years, and what is the break even. Okay, so we'll just change this. Or okay, so and then along with that, compute the cost of running the same server in AWS. Okay, and tell me what is the break-even value of n. Below which AWS is better, and what is beyond which your own data center is better. So basically, see, like if n is 1 million, if you want to run 1 million servers, you have a need to do that. It will be better to build your own data center, because why would you want to pay AWS to do that? But if n is 10, if you want only 10 servers, then it's obviously better to use AWS. So, but the thing in this assignment is that I don't want accurate numbers. I'm not after the numbers. I just want you guys to go over the exercise of the economics behind the cloud. And if I want kind of appreciate the difference between capex, opex, upfront versus fixed expense versus variable expense. So for example, hardware, no, not hardware. Yeah, some of the expenses are more fixed and some of the expenses are more variable. So, but do these things make sense? And you have 1 week to do this. So you need to do this by class number 3. And tomorrow, basically, the tomorrow's assignment will be essentially setting up an EC2 with with some features. So beyond after this, so this assignment is kind of writing and economics and all that. But after this, the subsequent assignments will be more technical. So please bear with me on that. But is this do you guys agree to this? Do we have a fact, 2 articles and 1 economic cost and pricing analysis? So this pricing analysis obviously has to be done in like a spreadsheet software, and don't spend too much time on getting accurate cost. I don't care about that. I just want you to go over the exercise of listing all the heads and then doing a basic analysis on how much it costs to build a data center. So Abhi, depends on what kind of management it is. So, for example, if you want to some management you can do through the AWS console also. So let's say if you want to start up a machine, but if you want to enter, go log in into a machine, you definitely need the key. Okay, guys, please give me feedback on the assignment. Do we have an agreement? Is this fair? Abhi says yes. What I need a go ahead from everyone. Aditya, Sarfraz is me not. Ankit, Avinash, are you guys there? Okay, Priyaranjan, thanks. King, thanks. And I'm here to support you. So whatever problem you have, uh, you know, I'm basically my role is to help you be successful, to make sure that you get the maximum out of this course. But I'm also I will I will hold you up to this assignment because that is the as I said, I believe that you will learn only when you put in the effort yourself. So this is important for me. It's important for you. It's clear that we are not. Don't worry about charging plan. I'll talk about a lot about the pricing tomorrow. In fact, Amazon pricing is so complicated. You can write a book this thick on pricing. And okay, let me also share with you one thing. So there's this web application that we okay. I'm gonna share a link to this application. We were crazy enough to try and build a cost calculator application for Amazon a few months ago, and I'll share a link to that as well. It'll tell you how what will be the cost of running a certain number of instances. And beyond that, I'm not looking for exact cost. I'm just looking for more of a framework to analyze the information. Yeah, of course, Amazon, everything. Okay, Amazon doesn't publish its cost, but Amazon publishes its prices. So cost is something that you assume whatever you want based on your experience, and this may also be reasonable. So Tim is from Netherlands actually, and your assumptions may be different from maybe the people working out of India. So but make assumptions. Whatever assumptions you need to make that don't worry about the exact number. That's not an expectation, and that won't be fair for me also, because getting the exact cost for it to build a data center is a tremendous exercise. Okay, but yeah, I wanted to show you. So this was for AWS EC2 pricing. So in fact, AWS has their own calculator. Okay, and by the way, what you will get in the next couple of hours, you will get 3-4 pieces of information from me. I'll tell you what those are. Uh, so you'll get number one, you'll get a login credentials for LMS. Number two, you'll get login credentials for AWS. But again, please do not play around too much with my account, because it can be very expensive for me. And you will get a link to quiz number one. Okay, so this quiz, please take it before tomorrow's class, and this is just to reinforce whatever we have discussed in this class. Okay, so these are the things you get from me in the next couple of hours. Any so Abhi, I don't want to do the demonstration. I want you to use your mind and make your own assumptions. In fact, I'm sure if you Google for it, you should be able to find out this information. I think this information should be out there. What are the costs involved in making a data center? But I want you guys to spend the time and effort to figure that out. And actually, I don't even know the answer. I don't know how much it costs to make a data center. Okay, so assignment one. This is due on 7th December. Yeah, so use whatever currency you want, US dollars, Great British pound, euros, whatever. It's up to you. I can do the conversion if I want. Okay. Anything else? Any feedback that you guys want to share with me on this class? Any ways that we can make the next class better? I know that we really run beyond our schedule for this class. We are actually half an hour, more than half an hour the class duration. I'm sorry for that. But anything else? Any other way in which you suggest we can make the next class better? So feel free to share your feedback with me either right now, or you can write to me. Okay, and okay, we will get a few other things from me. I'm going to put the reading material on LMS. I'm going to put these slides and video on the LMS. Okay, Aditya, Avinash, Ganesh, Sudhir, Tim, any feedback that you want to share with me? Please don't be shy. If I'm doing something wrong, please tell me now, rather than suffering through this course. Okay, Tim, I'm sorry for that, but I think the next few classes will be more interesting, and I definitely promise that the assignment will be much more interesting than the than my classes. I promise that the assignments will be. Okay. Anything else that you want to share before we close for the day? By the way, meeting again tomorrow, same time, 3 p.m. India time. And then after the second class, the next two classes will happen at a 1 week duration. So it phased out so that and the reason it phased out is that you get enough time to do your assignments. And no, you will not have any more essays to write. You will only have more stuff to do on AWS. Okay, but by the way, if you guys are if anybody is enthusiastic about writing an article or essay summary of every class, I would really appreciate that, and it will really be valuable for me. And I'm sure it'll be good for you as well. So believe me, if if in every class you can pick up one topic and write a small article or blog post about it, you will get to know that topic in much more detail and much better. You'll be able to take that forward in your career in a very useful way. So if you can do that, I highly encourage you to do that. Okay. So anything else before we say final goodbye for today? Okay. So then I think we'll close for today. And good afternoon, good evening to everyone, and look forward to seeing you again tomorrow and continuing this class again tomorrow. So thank you very much for taking this course again. I'm very excited doing this, and please let me know anytime how I can help you, how I can make this course more useful and relevant to you. Okay, thank you. Goodbye then.